welcome. Thanks so much for being here.
Yeah, thanks for having me, Katie. I'm excited to chat with you and your listeners today.
I'm so excited to learn from you about this topic because I have not ever covered this topic specifically on the podcast before. And I feel like it's of increasing interest to all of us as we get older, and also that there's just not as much information out there about this aspect of health as there are about some others. So, we're going to get to go deep in several areas, but to start off broad, we're going to be talking about biological age. And I would love if you could kind of just give us a brief entry into what biological age is and what we're looking at when we talk about biological age.
Absolutely. It's a great starting point for everyone who may not be as familiar, but it's very simple, actually. Biological age, even sometimes referred to as physiological or this type of function, cellular based aging, is really a measure of how well or poorly your body is functioning compared to your chronological age, right? We know chronological age is based on the date you're born. That is only going to increase as time goes on. But biological age is really considering your cellular age, how various biomarkers are related to the wear and tear on your body, your health status, overall functioning of different organ systems. That's what's really going to address an individual's biological aging process. And that can increase or that can decrease based on evaluating the individual's health, kind of what they're doing, the environment they're in, if they're taking any supplements, medications, or involved in any other type of procedural based therapies as well, where they go into the clinic and get treatment.
Gotcha. And I would guess, like every area of health, but even more so in this area, there's probably a lot of individual variables that come into play when we're talking about someone's biological age. But how do we even measure biological age? Like, how might someone even know what their biological age is?
Yes, that's a great follow-up question too. So really there's a ton of ways you can measure biological age. And this sounds really silly, but for example, Katie, I could say, hey Katie, run from point A to point B. I'm going to time you and I'm going to incorporate it in an equation where I, create a biological age. That is still technically a biological age, but there's not going to be much validity or power to it. And that is really the point of these kind of biological age markers is how predictive of they are outcomes. And the way that we find the best way to make them very predictive is to really measure what we call epigenetics. So I'll start there, if that's okay. Epigenetics, really kind of means above or on top of the genome. Epi is a Greek prefix. So we're looking really at how your genes are being expressed compared to your genetics, right? Your genetics is going to be your hardware, where you get 50% from parent one, 50% from parent two. That is not going to change. It's going to be the same in every single cell type. So think of genetics as that hardware, right? It's that nature. And your epigenetics is going to be the software that's controlling that hardware. It's going to be the nurture. And everything and anything affects those epigenetic modulators. So again, it goes back to lifestyle. It goes back to your environment, your behavior, what you surround yourself with. So I like to define, epigenetics and genetics there. And underneath epigenetics, we kind of have all of these modulators. And more specifically, I really look at the DNA methylation markers to measure biological age, Katie. And that really just means, hey, are we turning these genetic markers on or are we turning them off?
That makes sense. And it makes sense. While there would be, I can see some correlation from like running, you mentioned. I know that sprinting, actually, your speed of sprinting can be an indicator of, for instance, your muscle mass and how much power you have. So I could see why people could use that for like a loose idea, but it, to your point, is not taking into account what's happening at a cellular level. Though it did make me curious. We hear things like grip strength is correlated to longevity, sprinting speed is correlated to longevity. And I know those don't tell us an accurate biological age, but do you feel like those are still good metrics to be aware of and to know and to like keep track of as we get older?
Oh yeah, absolutely. I think the sprinting speed is really interesting, yeah, because we know we're going to become slower as we become older. But I think probably the most validated like physiological biological age measurement is going to be that grip strength you mentioned, right? Because again, as we get older, we are going to I would say most of us become more weak, less strong. We're going to lose muscle mass as we age. So even muscle mass percentage, right? If you're doing kind of like an in-body or a body composition test, you can kind of measure your muscle mass as time goes on as well. So I think hand grip or grip strength using a machine is a pretty good indicator there that you can just measure over time to make sure you're not losing that strength.
That's good to know. I'll say on a personal level, it's more of an anecdotal, but I like having a gamified way to track it. So I do look at from the data I've seen grip strength, and so I monitor that relatively like often, as well as sprinting. I read the statistic that most people will never sprint again after age 30, and I decided I didn't want to be part of that most people, so I've been doing that. And then also apparently the number of push-ups you can do without stopping is also an indicator. So I know those aren't hard science, but I feel like they're fun metrics to play with as I get older. But I love that you're helping quantify the actual cellular aspect of this and knowing really what's going on in our body from something we cannot see from the outside, because it seems like this is totally separate of if we're getting crow's feet or if we have, aging damage on our skin. This is actually looking at our biology. And you mentioned the epigenetic side. I know this word gets tossed around a lot in the health world, and it seems like it's not completely understood yet. So can you elaborate on when we're talking about epigenetics, like what are the big factors that we're looking at and how can those vary among people?
Yeah, exactly. So I'm going to dig into that kind of epigenetic modification that we specifically measure, because really there are a ton of epigenetic modifications, all sorts of little chemical processes going on that are really going to change the expression of your DNA. But I always come back to this DNA methylation marker. That's exactly what we're measuring, Katie. And all of that means is we're just talking about a little carbon, a CH3 group, a carbon and three hydrogens. If that molecule is present, we say that position is methylated, meaning that gene is going to be less expressed. And the same thing is true of the opposite. If that molecule, that CH3 group is not present, you're going to be unmethylated. And then that gene is going to be turned on. So there's this balance. It's not the idea of, hey, I want everything turned on or I want everything turned off, right? That was kind of an original thought, maybe even just 10 years ago, where as we age, mammals in particular gain methylation, meaning you're turning your genes off as you become older. Which is true to a sense, but what we're starting to understand now is, things go awry as we age chronologically. Some things are turned on and some things are turned off. So my goal really when it comes to measuring my biological age is I want to shift those methylation markers in my favor, whatever that means for my personal biology. So I'm turning things on that I want on and things off that I want off, because it's really about that balance. And a good example I always like to give too is you want your cancer genes or your oncogenes to be methylated and turned off, right? But you want your tumor suppressor genes to be unmethylated and turned on to help fight off that cancer. So it is very, very site specific. And, I think we'll get to a point eventually where we can give you a map of your methylome, we call it, kind of all of these DNA methylation markers, and say, here, Katie, here is your, really pretty report. Here's your status right now based again on your environment and what you're doing. Here's where you need to be, and here's what you need to do to get to that point. I think we'll absolutely have that eventually.
What's exciting to me about this is it seems like this starts to answer that question of the personalization and individualization when it comes to health, because I say so often, we can learn something certainly from everyone we encounter and from every expert's approach and protocol and program. However, I caution people against assuming that what the blueprint exactly that worked for someone else is going to have the same results for them, because we are all each so different. And I feel like this starts to help us actually figure out those same variables for us and understand why what works for one person won't work exactly the same for everyone else, but to get answers on our own. Are we at a point with data where we can get these results for our methylation and then understand some needle movers like levers we can pull to start to affect those within our bodies? Like, do we have reliable data on that?
Yeah, and that's really new data as well. And it's really, really exciting. It's a pretty foreign concept and something that we actually coined at my company. It's called these epigenetic biomarker proxies, or what we call these EBPs for short. And that's the idea, Katie, that we can actually give you a biological age, right? We can tell you how you're aging, which is again super important because it's the number one risk factor for all cause mortality and morbidity. So we need that number. We need to know where you stand. However, what I think is now more important and relevant, because we can do this, is we can give you kind of what you need to work on and what makes up that biological age. So those epigenetic biomarker proxies are very, very informative. They're kind of predictors of clinical lab values or proteins or metabolites that you need to work on to thus lower your biological age, right? Because everything you do has a cascading effect and changes epigenetics. So we can always come back to, hey, what actually makes up this biological age clock? And how can we, like you mentioned, almost gamify those metrics, whether it be through lifestyle, supplement, medication, procedural based therapies, I keep coming back to, and then lower that overall biological age. So it's getting really, really personalized, which I think is very exciting, because about a year ago, we could only say, here's your biological age. Good luck. Do a deep dive on your lifestyle factors, right? And it was rather intuitive.
Well, and you just touched on this about the link to all-cause mortality, and I think this is extremely fascinating because in researching for this episode and seeing stuff you've published before, you talk about aging as a disease, and it's helpful to know that biological age actually is such a strong indicator of all-cause mortality risk. But can you elaborate on, are there specific factors within that that seem to like really increase the risk, or how do we pull that data?
Yeah, definitely. If I understand what you're asking correctly, maybe just digging a little bit more into how it's related to mortality and morbidity. So one of the clocks we actually just created with Harvard is what we call our omic M age. And this clock is the best in terms of hazards ratio, or its ability to predict, meaning, hey, how can this biological age clock predict, all of these diseases downstream and even death itself? We got that clock really close to predicting actually death, because that's how we trained it. So with that omic MH clock, Katie, we can actually predict death with a 92% accuracy rate within 5 years. So that is huge, and that has never been done before.
That's incredible and amazing to think about. I'm also curious, you guys must see a lot of this data and be able to like sort of pull patterns. Obviously, it's going to be very dependent on the person's genes and their epigenetics, but are there any patterns that have emerged in a general sense that are either lifestyle factors that are positively affecting biological age or negatively affecting?
Yeah, of course. This is a big question as well, right? What can I do just from a lifestyle standpoint? I would say really in the epigenetic based markers, we can predict almost anything as long as we're training it correctly. I would say the top maybe lifestyle factor that's actually going to be correlated to epigenetics is really going to be smoking, right? We can look at someone's epigenetics and actually predict more accurately how much they've smoked across their entire lifetime, rather than a self-reported smoking status, because people tend to fib more, or maybe not want to admit, or just, forget if they've smoking a certain amount. So of course, smoking is going to be having a really negative effect on epigenetics, and thus increasing biological age, and same with alcohol consumption. So those ones are, rather intuitive. I would say, though, the four main lifestyle factors that I really like to group together, I call them the big four, the main four, are going to be, of course, nutrition and diet. It's going to be physical exercise and activity. And then it's going to be sleep and stressors, and not any particular order, but happy to dive into any or all of those as well, and give particular examples.
Yeah, I would love to dive into those. I'm curious though if the data is granular enough to separate. Obviously, I would guess most people are aware smoking is harmful for your health, but I know a lot of the biohacking world is into nicotine, isolated nicotine in small doses orally as like a kind of a nootropic. Is there any data to know if nicotine itself is harmful or if it's the smoking part that's harmful?
Yeah, nicotine has only been studied in a very, very small group in terms of biological aging, right? So we know smoking definitely accelerates that biological aging. I don't think there is enough data on actual nicotine itself as a standalone, but we definitely need more data there. I've seen more biohackers continue to do that, and was always interested, yeah, if it's affecting the biological age in that way.
Got it. Okay. Yeah, I'll be curious if data emerges on that as well. When it comes to diet and lifestyle stuff, diet especially, I feel like obviously this is a controversial world to enter, and there's a million different opinions on the optimal human diet, with a likely answer that it also is a very personalized equation for each of us. But from what you're seeing, are there any commonalities we can pull out on the dietary side that are potentially helpful or harmful?
Yeah, definitely. This is a really interesting, area of studies. A couple in particular are going to be the DASH diet and the Mediterranean diet. They kind of go hand in hand. So your dietary approaches to stop hypertension, it's going to be more white meat, less red meat, more fruits, more fish, more veggies, more legumes, more whole grains, less sodium, less sugar sweetened beverages. You're going to have decreases in the biological age if you're continually and habitually following those diets. And I think that's really the key there. The number one study I always talk about when it comes to dietary recommendations is actually going to be caloric restriction. That is the first ever um, really study published about a year ago in 2023 in January, showing a 10% overall caloric restriction in healthy non-obese adults over a 2-year period is going to cause what we call this pace of aging interpretation of biological age to be decreased. And that's huge because there are so many animal studies behind this. None of us are mice or, flies or any type of animal model. So we really always have to come back to that human data if it's available, which is really, what I specialize in and who we're running these tests on. So main point being, that's going to be something that's going to inhibit mTOR, which is essentially this growth factor in the body. Other things that are going to mimic that would align with caloric restriction, if we want to go more supplement or medication based route 2, would be things like your broccoli extract, your sulforaphane, obviously very has to be well sourced, and then things like rapamycin, which I know are hot topics in this space.
That makes sense. Okay, so on the physical activity side, it seems like there are also an equal number of differing viewpoints about what is the optimal amount, type, duration, et cetera, for humans. Have any patterns emerged that you guys are seeing on the epigenetic side, or perhaps what would be what we're seeing a minimum effective dose if someone wanted to kind of optimize these factors and is like, as a mom, time limited?
Yeah, yeah. So I think that, speaking to all of the moms out there as well, just start moving, right? Moving your body, even 15 minutes, 20 minutes a day is actually going to make a massive difference as it comes to the biological aging. And I know sometimes I'm like, oh, I don't have time to go to the gym, or I don't need to do anything at home either. But even if it's just the yoga, kind of the mind exercise, whether it's meditation or breath work, all of that can have a substantial effect on the body as well. So we definitely need a balance, right? We want to exercise in various ways, but I think the key is not too much. That's why even doing a little bit of something is going to have a major effect. So we want to mix aerobic based exercise. So exercises that are going to help increase our kind of lung capacity or lung function. They're going to be more long distance, think longer cardio, endurance, hiking, biking, swimming, and anaerobic based exercise as well. So those kind of short breath exercises. So think more lifting weights or hit or a hit particularly on the treadmill or kettlebell swings, something of that nature. So usually we see a lot of these measurements from a physical exercise standpoint in lung function. Our results in particular from several studies show a consistent correlation of epigenetic clock acceleration with the decrease in lung function. And that's going to be measured by what we call FEV1 or forced expiratory volume. And that goes across, all things on the board. Again, grip strength, gait speed, FEV1, and then your VO2 max as well. So I know when we talk about VO2 max, right, that's another really great longevity marker too. It's really hard to do unless you're in person. But funny enough, Katie, we even have like a VO2 max epigenetic biomarker proxy where we can give you an estimated VO2 max just by looking at those epigenetic markers.
That's fascinating. And I have gotten to do the VO2 testing and RMR and DEXA recently. And I will say you're right. It has to be in person and it's a little bit of an intense test. Like it's not going to be your average, like wake up and just go do it with no prep and it'll feel great kind of test. But I feel like those are such fascinating markers to just be aware of. And like I said, ones that I'm keeping an eye on as I age. I felt like the DEXA was a semi-humbling, but also really enlightening data set to get, because my goal is to see my lean muscle mass and bone density actually increase as I get older. And I felt like that gave me a really cool picture into that, and got to see other markers like, for instance, visceral fat was extremely low, which is, I feel like, also a great sign from what we know in the data, but something to like keep an eye on as I get older as well. But I love that what you're doing seemingly is kind of like one test that's a lot easier than all those ones that I did, that can give you a pretty accurate look into what's going on and if you're able to improve it. And as we're talking about these things, I'm curious, for instance, I had a friend who went through your testing and found out biological age was much higher than expected, and then chronological age. Are you seeing people able to actually reverse or lower that biological age, or is it more of just being able to stop the progression?
Yeah, that's a great question. I think you can really dive into the details there, and every single researcher you ask, every single person you ask in this space, they're probably going to give you a different answer, right? We always go back to, if you say you can reverse biological age, what really is biological age? Right? Again, what does that mean? Reversing it, what does it mean? I would say if you're going to define that as, your friend, for example, taking a test, they see they have an older biological age compared to their chronological age. Can you and can you actually put interventions in play into your lifestyle, retake the test and see a younger biological age number? Absolutely, that is possible. And it's going to be possible through things that we're talking about now. So like you mentioned, the VO2 max, right? With our testing, if you actually see increases in your VO2 max between test one and test two, pretty much guaranteed that your biological age is going to go down as well, right? So again, those epigenetic biomarker proxies, I come back to them because they add that personalized guidance that can gamify and tell you exactly what you need to work on.
That's so interesting. And I'm so excited to actually test this and see what my own personal data is. Since most people listening are moms, I'm also really curious about any insights we have into different phases of life related to epigenetics and biological age, especially, for instance, pregnancy and menopause. I feel like would be top of mind topics for a lot of the moms listening.
Yeah, definitely. This is a great question as well. So there's one pretty famous study, I would say, talking about biological age and stressors. And in this particular study, it was done by Dr. Jesse Poganik out of Harvard, and he works with Dr. Vadim Gladyshev in the Harvard lab. It's I would say one of the top labs in the U.S. really studying aging biomarkers and looking at these measurements of biological age. They really looked at three stressors, and those three stressors included extreme cases of COVID-19, both elected and unelected surgeries, like if you're coming in for a hip surgery, and then pregnancy as well, because we know pregnancy is going to be a really large stressor on the body. In particular, what they found is all of those use case scenarios actually increase those biological age clocks. However, once they test afterwards, they actually see decreases in the biological age. So you're recovering. And I think the actual title of that paper is Biological Age is Increased by Stress, but it's restored upon recovery. So you're just getting these transient effects that, again, you'll be able to actually come out better afterwards, or even push past the baseline. So I think that's super hopeful that we know we're undergoing this larger stress, after pregnancy, 3 to 6 months. We've even seen some internal data where we have some people take the test and they see their aging markers really shooting down, even negative.
That's great to know, especially as a mom who's had 6 kids, that it actually can have a positive effect, which makes sense because we as humans were designed to reproduce and have babies. But it also makes sense that if measuring during or right after, you would see that change in biological age potentially in the direction you don't want to go. Because I know I've read a lot of data about how pregnancy, your metabolic demand is so much higher than the baseline that it would be equivalent to like running a pretty extreme distance every day, just as far as all the things happening in your body to support the pregnancy. But awesome to know that it can actually have a even more positive rebound effect. Are there any things in light of that, knowing that it's going to at least have that short-term kind of hit on the body, that people can do during those phases, especially to be extra supportive on the body, that we can understand from a biological age perspective?
Oh, that's a great question. I actually don't ever think I've gotten that question before. Simple answer would be no. The studies just haven't been done. But I think, again, if we're thinking about the research that is out there, really, finding a community, which is great for what you do, Katie, and bringing everyone together, right? As you're going through that time, there's so much research out there about your kind of quality of relationships when you're going through that period. And I'm sure that's probably why we actually see the biological aging even driven back down after pregnancy is not only because, I mean, your body is changing physiologically, but you also have this, new human in your life, right? That you probably love more than anything. I'm not a mom myself. I definitely want to be at some point in my life. But there has to be some type of connection there too. So I think, again, really not being patient, being kind with yourself. There's a lot of research talking about your epigenetics as it relates to psychology and even your thoughts, right? How you process thoughts, how you treat yourself, kind of that internal monologue you have. So I think making patience for yourself, being kind to yourself as well during those times, goes farther than we know.
Yeah, that seems like great advice across the board. I'm also curious if there's any insight into how things like assistive reproductive technologies affect biological age in a positive or negative direction.
Yeah, that's a great question. So those assisted reproductive technologies or art, like you mentioned, are going to have an effect. And it kind of is something you would again think is rather intuitive. So um, there's a researcher I really like from out of Europe named Christine Halftorm, who actually talks about even measuring a gestational age through analyzing DNA methylation patterns. And that's really important because then you start to understand the risk and implications of things like preterm and postterm birth on infant health. But defining kind of that gestational age for when you're pregnant can revolutionize a lot of prenatal care, provide, deeper insights into fetal development, allowing for like earlier detection of even like developmental based issues and more tailored interventions to help healthy pregnancies and to support that. But they also talk about the assisted reproductive technologies as well. And I think as that relates to epigenetics, there's still a lot of unknown just because we don't have the outcome or the follow-up data, right? So we do know that there are epigenetic changes with assisted reproductive technologies, but really we need to start to understand, okay, we are following these children who were, went through the reproductive technologies and who did not, what types of outcomes do they have later in life? And I think we don't have that research quite yet, but we definitely know that there is a connection there.
That makes sense. What about for all the moms listening? We might get questions about epigenetics in children, if kids can be tested on this, and if like what the data says about people under 18 and their epigenetics.
Yeah, that's a hard one as well. I love all these questions kind of interpreting and encompassing all of these phases of life, right? So there's a lot of developmental, what we call plasticity in children, right? Children's bodies are highly responsive to these environmental cues, and epigenetic changes during early development can really influence kind of how we are later on in life, our susceptibility to even certain diseases. So those particular changes can really affect children's growth, their metabolism, their brain development, and their immune system function. And we have a lot of prenatal and early life exposures too. One of my favorite things to talk about is even it's a mouthful, but it's epigenetic transgenerational inheritance, where mom, grandma, great grandmother, and even older generations can kind of pass through these epigenetic modifications to their children. Quite literally meaning what you're doing right now. If you're a mother or you want to be a mother, right? Katie, you mentioned you had 6 kids during your pregnancy, and even before that, even your mom, you actually pass things on based on how your epigenetics was at the time, which is really, really crazy to think about. Again, less human studies in that realm, just because you have to follow people over those generations, and that's definitely harder to do. So prenatal early life exposures like maternal stress, diet, smoking, pollutants, they can lead to epigenetic modifications that can predispose children to health issues like obesity, diabetes, mental health disorders, even. We know for a fact certain nutritional deficiencies or excess nutrients in the womb can actually alter the methylation patterns of genes related to certain pathways. So those are a couple connections there. I would say in terms of biological age in children, we do know it can be accelerated due to household environment. But the biological age clocks can sometimes act a little odd in children when you compare them to adults, but there are some specific biological age clocks created for children too.
That makes sense. And yeah, to your point, I know there aren't many human studies on that, but I find the mice studies on the epigenetic inheritance side so fascinating. And I feel like the good news of that, or at least how I look at it, is that means we can also pass on generational strengths. And so as more parents become aware of these things, it hopefully can also create a positive change for future generations as well. And I guess from a practical application perspective, if, for instance, both parents in a family get their epigenetics tested and know like what are the factors that are going to be most beneficial for them, making those sort of household changes in the house would also seemingly have a benefit to the children who share the genes of both parents. And probably any of these factors we talked about that move things in a positive direction would also be beneficial for kids, potentially to an even exponential degree because they're still in that growth phase.
Yeah, definitely. And I think, a lot of people talk about epigenetic transgenerational inheritance in a negative light, just because they're measuring like toxins or pesticides or certain things like that. We don't necessarily talk about it in the flip side. One study that some of your listeners may even be familiar with, if you remember back to the biology days and even, eighth grade or high school, there's the agouti mouse study. This was by Dr. Randy Girdle, and that is the first time ever we really knew that mom mouse study taking supplements um, while she was pregnant is actually going to give her offspring a better phenotype or a better coloring. And it's called the agouti mouse study because they look at the agouti mouse gene. So taking supplementation methylates this agouti mouse position, meaning it's turned off. And when that happens, you have a healthy mouse with brown fur. But when you don't take that supplement and it's not methylated and that agouti mouse gene is turned on, you get this mouse with like yellow fur. It develops obesity and actually disease during adulthood later on in life. So that agouti mouse experiment is just a classic study in the field of genetics and developmental biology. It really involves everything we've been talking about, which is the manipulation of a specific gene we're targeting. Again, that agouti gene for the mice to really affect on the coat color and the obesity or other diseases later on in life.
That's so interesting and exciting to think that we might see a point in our lifetimes where we can have enough personalized data to know, like for me specifically, if I were going to have another baby, what would be the things that could be most helpful to that baby's entire future for me to know pre and during pregnancy. And to be able to like draw that personalized data is so interesting to me. Um, I'm also curious to go through kind of some rapid fire points that I'm curious if we have data that are like semi-controversial, but I would love to know if we have enough ability to find this out for ourselves in what can be beneficial. For instance, you talked about mTOR, and we also talked about lean muscle mass, and we know that protein consumption can affect sort of both of those things. There seems to be a lot of debate around how much protein do humans need to consume, if too little is bad, if too much is bad. And I would guess there's also an extreme level of personalization based on our epigenetics. But is there anything you're seeing in the data that can give any indication of an optimal range of protein consumption for humans?
Great question. I feel like I see this everywhere when I open like my social media accounts. Um, so you want enough protein, absolutely, in your daily intake. I think some people definitely get too much, and I think we can see that in some of those individual epigenetic biomarker proxies that we measure. We have a protein, the insulin-like growth factor binding protein 2, that we can actually measure in a quantitative way to say, look, this looks way too high or this looks way too low. You need to change your protein intake, and a couple other protein related epigenetic biomarker proxies too, like albumin, for example. So when you do see those people, who are always in the gym and, eating a lot of protein, I think you can overdo it to a sense. You also want to have enough to replenish your body to make sure you're healing in between those gym sessions. So it's really a healthy balance. I think even listening to your body goes a long way as well. I know I always feel better when I'm hitting that protein target and actually tracking that. So my recommendation really to anyone is to just start tracking it, right? Like actually write it down. And you may be surprised at how much you actually eat per day, or how small of an amount you actually eat per day. I do like the rule of just, if you're trying to maybe put on a little bit of muscle mass and you're working out and you're actually eating good protein, just do a 1-to-1 ratio. So if you want to be at, 140 pounds, try and eat 140 grams of protein, is my rule of thumb.
Good to know. And I'm excited, like I said, to see my own personalized results on ways I can optimize that even further. Another area that is semi-controversial, and I will admit I have a definite bias here in favor of, but I feel like for decades we've been getting the advice to avoid sun exposure almost entirely. And we know that statistically humans spend almost all of our time indoors to an extreme degree and often cover up or avoid the sun even when we are outside. So my bias is in favor of healthy and appropriate sun exposure, especially things like morning light and enough sunlight to signal the hormone cascade that goes far beyond just vitamin D. But recognizing I do have a bias here, I'm curious if we see anything in data on this and any insights you would have, strictly because I feel like every other organism in nature, from plants to insects to animals, make sure to get enough sun exposure in the right amounts for their bodies. And I feel like humans maybe have missed the mark a little bit on this recently. So I'm curious if there's any insights there from the data.
Yeah, definitely. So first and foremost, I agree with you as well, right? I think a healthy amount is definitely worth noting. So I think there's a lot of epigenetic changes if we're just talking on a cellular level due to sun exposure, right? So with DNA methylation, if we're sticking there and we're talking about that, we know too much, right? UV radiation or tanning beds, X-rays, certain things that are going to give you these heavy radiation amounts from sun exposure, even if it's extreme, can cause more negative effects in the DNA methylation patterns of skin cells, right? So you have to be careful if you're exposed or have an increased propensity to develop skin cancer later on in life. I think that it plays a little bit more of a genetic component, but it's still worth noting, right? We want to wear sunscreen, we want to be protective at some points, but we do still want to have that direct sun exposure. So that could cause eventual, skin damage. We just want to protect against UV radiation while we're doing it. I think, as it relates to biological age and epigenetics itself, there aren't any studies that I at least know of in terms of the correlation or the connection between the two. I think one thing, though, if we are talking about environmental factors like sun exposure, it's not directly related whatsoever, but actually the more time you spend in green space or around trees and nature, that has actually been shown to decrease your biological aging, and it actually increases IQ in children. That's one of the studies in children as well. So they did kind of a study where they compared, children who weren't as exposed to green space or even having just plants in the house compared to those who weren't, and later on in life measured their IQs, and you could see statistically significant differences between the two. So I'm trying to go down that nature path a little bit for you and extrapolating that.
That's so interesting. And I'm going to put that as another pro in the category of why I have so many houseplants and probably a houseplant addiction, but I'm going to say it's backed by science now. Um, and it makes sense on the nature side. And I feel like if we look at the data and we're able to do this more and more now with increasing amount of data and also ability to interpret it thanks to algorithms and AI, but it seems like the strong correlation I've noticed in the research was the number of extreme sunburns you have definitely correlated with not being good for your body, but normal physiological sun exposure, especially those like sunrise, sunset, and the right amount of midday sun seem like in general helpful and protective against a lot of the other factors outside of just skin cancer and vitamin D. So that's helpful to know that you guys are seeing similar things as well. This one's going to be harder to quantify, but we talked a little bit before we started recording about community and relationships and doing things together with other humans. And I have a friend, Dr. Lauren, who says humans are nutrients, and a lot of us are deficient these days. So I would guess it might be harder to epigenetically quantify, but what do we know about relationships with other humans, interactions with other humans, and how that affects our biological age?
Yeah, absolutely. I think it's massive. I hinted on this a little bit earlier as well. It's even worse. Being lonely, for example, is even worse than smoking. That research actually came out of Harvard as well. So it just speaks to the volumes that it's not necessarily the quantity, right? It's not all of the contacts you have in your phone per se, right? How high that number is, but who are you willing to call when you are distressed or there's an emergency? Those are the contacts that you should really be thinking about, those quality relationships, those people that you can really rely on, and it being a two-way street, right? You share with them, they share with you, and you have this fruitful relationship, and it's something you can sustain throughout your entire life. I think we also hinted, Katie, before we hopped on, even talking about very briefly maybe some of those blue zones, right? Why do these people in these certain areas live longer? Even there's areas even in Costa Rica, which I don't think is technically considered a blue zone yet. But even people who live in poverty in Costa Rica, they live until they're, 105, 110 years old, right? It has nothing to do with their socioeconomic status, rather their actual community and their relationships with one another and being able to support each other even through those hard times. So that's a big factor of the blue zones. And then they're also finding that outside of the blue zones too. So they're going to be a little bit different. But in this world that we live in, at least in the US, when we're working nonstop, we're full of stress, we're maybe not putting as much effort into that quality time. Quality time is like my number one love language. So I love sitting down and like talking with people and really getting to know them. It is massive. It's, a therapeutic intervention for people, right? And goes to the fact too that we talk more about this like functional interpersonal type of medicine, where actually the doctor is spending more time with you and getting to know you as a person, right? You're going to see your health, you're going to see better outwards phenotypic expression for your body when you actually start to increase the quality of those relationships. So there's a lot to talk about when it comes to that.
Got it. That makes sense. And hopefully something I feel like we'll see more data on in the future. Something that I find many of these things, these foundational things, humans have intuitively known forever. And now the science is confirming for us or reminding us of what I feel like humans have always known. Are there any other less intuitive factors that come into play with biological age that we haven't gotten into yet, or things that might surprise people about what you guys see?
Yeah, there's one I actually wanted to bring up. I can't believe I forgot about this. I thought would be super interesting to your listeners. So there's a company called Diagnostics or Digital Health. They are led by an amazing kind of scientific advisory board and leaders. They can actually predict postpartum depression when you're pregnant through your epigenetics, just through a finger prick blood spot card. And I think we'll start to see more and more of these tests become available where, if you could, and two of my best friends just had babies, it's amazing and it's been great. If I could have tested them beforehand and say, okay, this is your chance of actually getting postpartum depression. Oh, if it's really high, you need to start intervening now, right? And then we need to test you in a month or 2 months and make sure that number goes down so you can actually be present postpartum and, feel good about yourself. And I think, postpartum depression often goes super unrecognized. A lot of affected mothers can confuse that with just stress of having a newborn, or fatigue, which really hampers your treatment initiation anyways. So it's just kind of a diagnosis which really gets slipped under the rug and not necessarily even treated. So I really think, like you mentioned, that the science is there. We know a lot of these diseases, especially the physiological based diseases, are going to increase biological age. But I think the question we have to ask ourselves then is, how do we quantify it? Is there an algorithm? Is there AI where we can actually make this a physical outcome? And then what can we do about it to change it? And when do we actually retest? So I think that's a really cool example, just because one, it's really relevant to you and to this group. But number two, I think it's a model that we'll see a lot of people starting to replicate. And the testing isn't available yet, but it will be, I think, within the next 3 to 4 months or so.
Seems like it's going to be a very exciting next decade as we're able to actually apply more of this knowledge in a very specific way for specific people. And we've talked a lot about the details of what we can learn from this type of testing. Definitely, I want to spend a little bit of time explaining to people where they can get tested, how they can get tested, and also like maybe some expectation setting if they get a result that might not be what they hoped for, like some kind of hope message of what they can do with that data, understanding that inside of themselves.
Yeah, of course. So anyone who's like, oh, I really don't want to know, or I'm going to be, 80 years older. It's not possible. You won't be that much older. I promise you. We haven't seen that quite yet. But if you're curious, just test, just get started, get a baseline. You don't have to be your healthiest. In fact, people who do end up testing always say to me, oh, I wish I would have tested, a year or 5 years earlier when I was super unhealthy. So I could actually see these changes that I was making was reducing my biological age being that number one risk factor. So my number one piece of advice to people is, yeah, just get tested. If you're curious, just get tested. We have two products at TruDiagnostic.com. We have our complete kit, which includes everything. I definitely recommend going for that one first because it's just very all comprehensive. We have a cheaper one called TruAge Pace, which just includes two of our outcomes, being this pace of aging, Dunedin pace metric and telomere length. It's good. for those who are maybe just wanting to dip their toes in the water, again, check for frequent follow-up therapy. It's really good for N-of-1 precision-based testing, but you can go on the site, order a kit. It's just a finger prick blood spot card, really easy. You send it back to our lab that we own in Lexington, Kentucky. We'll have your results back for you in 2 to 3 months, 2 to 3 weeks after the time we receive your sample. And then, Katie, I know, if anyone takes the test as well, that's a listener, I'm happy to even do a one-on-one consultation with them if they're interested.
Amazing. Well, we'll put all of those links in the show notes for you guys listening on the go. That'll be at wellnessmama.com. And maybe after hearing this episode, hopefully you listen while going for a walk, maybe outside, getting some green space and some sunlight and hydration and all the things that can be beneficial. But I'm personally excited to do this test. I'll report back to you guys on what I find out, even if it's not the data I want to see or the number I want to see. I'm excited to go on this journey. And Hannah, this has been such an enlightening conversation. I really appreciate you spending the time and getting to go so deep on a factor that I feel like is only recently able to be tested and still not super well understood. I know I learned a lot, but I'm very grateful for your time. So thank you for being here.
Yeah, thanks so much, Katie. I appreciate your time.
And thank you, as always, for listening and sharing your most valuable resources, your time, your energy, and your attention with us today. We're both so grateful that you did. And I hope that you will join me again on the next episode of the Wellness Mama podcast.